Hello friend, welcome to my YouTube channel Electrical Boost. Today we are going to discuss what is the Lenz law and what the importance of the Lenz law. What the importance of Lenz law. In our previous lecture, we know how the EMF will induce by the law of Faraday law of electromagnetic induction. But we did not know what is the exact direction, what is the exact direction of the induced EMF, exact direction of the induced EMF. When in this case, in Faraday law, we know that if we change in magnetic field, change in magnetic flux, caught with a closed circuit or conductor, caught with a closed circuit or a conductor, change in flux means towards this or movement towards outside. Okay, it will induce an EMF. It will induce an EMF. But we did not know what is the direction of the current. Direction like this direction or this direction. We did not know what is the direction of this induced EMF. From Lenz law, we are going to derive what is the exact direction of EMF. Okay. This law, Lenz law, is formulated by famous physicist Emil Lenz. By the name of Lenz, it law called as Lenz law. Okay. Then we are going to what is the definition say? What is the definition Lenz law definition say? From this definition, we derive a motionary picture. Then we clearly understand what the scenario going on. Okay. Let's say that Lenz law said that the current induced in the circuit due to change in magnetic field. The current induced in the circuit due to this change in magnetic field is directed to the opposite of the change of flux. That say what amount of current is induced, that direction is always opposite the change in flux, and exert a mechanical force which oppose the motion. That means Lenz said that what amount of current will induce, it will also produce some flux. What amount of induced EMF, it will also produce some flux. That flux always oppose that main flux, the change in main flux. That means if the magnet moves towards this coil, the flux line of flux like this way. Okay, it will produce the flux like this way, so that it will oppose the main flux. That is the Lenz law. If the magnet move away from this coil, it will like this, flux like this reduce, so it will attract towards. This is the flux of it, and exert a mechanical force, which oppose the motion. That means I derive a question. Let this is stand still. Okay, if the magnet close to let this north pole and this is south pole, let this is a coil facing towards this. Okay, if it is nearer to the magnet is nearer to this flux, that means the magnet move like this, Here is the definition. It will exert a mechanical force. This coil exert a mechanical force which oppose the motion. The oppose the motion means the motion towards this coil. It will, if if he want to oppose this force, if he want to oppose the motion, that means if exert a force to repel, exert a force to repel, exert a force to repel. So if this phase is north pole, if this phase is north pole, then it will repel. We already know in the magnetic pole, same pole repel each other, then it will oppose, this motion, is oppose the motion. If let's consider, if this magnet north pole and south pole move away from the coil, move away from this coil, move away from this coil, then the motion of the magnet towards this direction, so it will oppose. That means when it is opposed, that means it will attract, means this direction. Okay, so attract means it will create south pole, so that this motion can attracted to stop this movement, of this magnet, motion of this magnet. Okay, first if the magnet moves toward the coil, its face will north pole, and if the magnet moves towards this away from this coil, it will south pole. From this we decide what is the direction of EMF or direction of current. In the right hand thumb rule, we know that right hand thumb rule, I draw it, the painting is not good, but I hope you understand it. Okay, sorry, it is like this. This not good figure. Okay, if you consider this is, this is a north pole, facing towards this, and this is south pole, then the current will move like this. If the coil facing like this, okay, then current will like this. The current, this is consider this facing towards me, then the current will flow like this direction. If the south pole this side means north pole this side, downside, so that the current will flow like this. This is the right hand thumb rule. From this we decide what is the current. Okay, here we say what is the exact direction of this induced EMF, in previous lecture I say that induced EMF equal to minus d phi by dt, n d phi by dt. Okay, the way this negative sign due to the Lenz law, that means it will oppose the main flux, so that negative sign always opposite direction to the main field, so that we give a negative sign or insert a negative sign from this final EMF equation, Hope you all have you understand this question, this law. Okay, hope if any doubt please comment. Thank you for watching this video. Please like and subscribe my channel. Thank you.